Welcome back to my channel RB Maths Academy. Before watching this video, make sure that you have watched part 1 to part 7 of Introduction to Trigonometry. If you face any difficulty in trigonometry, then press I button on the right upper corner to get the complete information on trigonometry, and the link of all the videos are given in the description box also. Now, in this video, we are going to discuss few more questions on the identities, trigonometric identities. So let's take a first question. The first question is tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta is equal to 1 plus sec theta cosec theta. I know many times students face a lot of problems in proving the identities. So few things you have to keep in mind before solving any identities. You should know all the algebraic identities. A plus B whole square, A minus B whole square, AQ minus B cube, AQ plus B cube, and so on. So you should know all the identities, the algebraic identities. You should know all the trigonometric identities. You should know all the formulas of the trigonometry very well. And I have explained all the formulas in very easy manner in my previous videos. So if you know all the formulas very well, then you will not face any difficulty in proving the identities. Now, here you can see on the left hand side it is written tan theta upon 1 minus cot theta plus cot theta upon 1 minus tan theta. So most of the time what happens, if you have given tan and cot, generally we convert into sine and cos. See, few things you have to just steps remember. Either we just convert them into sine and cos, or sometimes we take LCM, and if they are making an identity, then we do not convert them into sine and cos, we just try to make in the form of an identity. And sometimes if square root is there, then we have to multiply both numerator and denominator by its conjugate to just remove the square root from the denominator. So now it is written here sec theta and cosec theta. So you know that sec theta is a reciprocal of cos and cosec theta is a reciprocal of sine. So what we have to do, we should try to bring sine and cos on the left hand side. So this is my question, that is tan theta upon 1 minus cot theta. So first we'll write the formula of tan theta, that is sine theta upon cos theta, and this is 1 minus cos theta upon sine theta, because cot theta is cos theta upon sine theta. So C for cot and C for cos. So remember, in cot, cos will come in the numerator, and in tan, sine will come in the numerator. So cot theta is equal to cos theta upon sine theta. Then you can write 1 minus, put the value of sine theta, tan theta, sine theta upon cos theta. Now what we have to do first? First we will just simplify by taking LCM. Now this is sine theta upon cos theta. Now take the LCM in the denominator. So you will get sine theta minus cos theta upon sine theta. Now this is cos theta upon sine theta. And here in the denominator you can write cos theta minus sine theta upon cos theta. Now, what will you do in the next step? Just simplify first. So this is sine theta upon cos theta. This sine theta will go in the numerator, so it will become sine square theta. And here you will write sine theta minus cos theta. Now, similarly here you can write cos theta. This cos theta will go in the numerator, so it will become cos square theta. And the denominator you will get sine theta. And the bracket you will get cos theta minus sine theta. Now, what happened? We can see here, this is sine theta minus cos theta. This is cos theta minus sine theta. So the terms are same, but only the differences of the sign. So we have to take minus sign common out of this bracket. So we will get sine square theta upon cos theta This is sine theta minus cos theta. And here you can write cos square theta. And in the denominator, you can write sine theta. Now we can write it as sine theta minus cos theta. Because here I have taken minus sign out of the bracket, so minus will come here. And in the bracket, you can write sine theta minus cos theta. Because whenever we take minus sign out of the bracket, the sign of all the terms will change. Here cos is positive, here cos is negative. Sine is negative, here sine is positive. Now you can just take the LCM. Because whenever the terms are coming in the fraction form, always you have to take the LCM. So we will get cos theta, sine theta, and this is sine theta minus cos theta. So you can see here cos theta and sine theta minus cos theta is already written here. So sine theta into sine square theta, you will get sine cube theta minus the sine theta into sine theta minus cos theta. It is already written here. So what is left? Cos. So cos theta into cos square theta means cos cube theta. So we know the identity a cube minus b cube is equal to a minus b, a square plus ab plus b square. So we will use this identity. So here your a is sine theta and your b is cos theta. So you can write sine theta minus cos theta in one bracket. In another bracket, you will write to the square of a, that is sine theta. So we'll get sine square theta plus a into b means sine theta into cos theta. You will multiply only trigonometric ratio, no need to multiply a side. So you will write plus sine theta cos theta plus b square. So your b is cos theta. So cos theta, square of cos theta means cos square theta. So we will get, now in the denominator, we will get cos theta, sine theta minus cos theta. Now this is sine theta minus cos theta. So we will cancel out. Sine theta minus cos theta, this one will cancel out. Now we can write here sine theta into cos theta plus, now if I write sine square theta plus cos square theta, we know this identity, so it will make 1. So we will get 1 plus sine theta cos theta upon sine theta into cos theta. Because we know that here sine square theta plus cos square theta is equal to 1. We should know this identity. Now separate them, you will get sine theta cos theta upon sine theta cos theta plus 1 upon sine theta cos theta. Now you will get it 1 plus, now this is separated, 1 upon sine theta into 1 upon cos theta. So we will get 1 plus cosec theta into sec theta. So this is nothing but the right hand side. So you should know the identities, algebraic identities, because we have used algebraic identity a cube minus b cube is equal to a minus b square plus ab plus b square. You should know all the trigonometric identities. So if you know all the identities very well, then I don't think that you will face any problem. Now in this question, you have given cos a minus sin a plus 1 upon cos a plus sin a minus 1 on the left hand side, and you have to prove it equal to cosec a plus cot a. Now we know that cosec a is the reciprocal of sine and cot is cos a upon sin a. It means we have to bring cos and sine in our question. Fine. So when we solve left hand side, so it is already given that cos and sine, it is written in the form of cos and sine, but we have to bring in the denominator. So whenever you have given 3 terms, then what we have to do first, just make a pair. Write these 2 terms together and treat it as 1. In the denominator also, you have given these 2 terms and just you can make it as a 1 term. Now what we have to do, we have to just multiply both numerator and denominator by its conjugate. So we can write it as cos a minus sin a plus 1. And this is cos a plus sin a. We can write it in the one bracket, and this is minus 1. Now multiply by its conjugate of the denominator. So the conjugate of cos A plus sin A minus 1 is, you will get cos A plus sin A plus 1 upon cos A plus sin A plus 1. Now what we have to do, we have to just multiply both numerator by numerator. So if you multiply this bracket cos A minus sin A with cos A plus sin A, then you can know A minus B, and A plus B is A square minus B square. So if I multiply this by this bracket, then I will get cos square A minus sin square A. Now multiply this whole bracket with 1. So you will get plus, because when you multiply any number by 1, you will get 1. So you will get that number. So if you multiply cos A minus sin A by 1, you will get cos A minus sin A. Now again, when you multiply this expression with 1, again you will get the same expression, that is plus cos A plus sin A, and plus 1 into 1, that is 1. Now come to the denominator. You can see here denominator is in the form, this is A, same, and this is B. So you can see we can write the formula A minus B and A plus B, that is A square minus B square. So our A is cos A plus sin A whole square minus 1 whole square. Now in the numerator, if you see that you can find that sin A and sin A will cancel out. Now you can write cos square A. Now 1 minus sin square A. So you know that cos square A plus sin square A is equal to 1. So cos square A is equal to 1 minus sin square A. So we can write cos square A in place of 1 minus sin square A. And here cos A is coming 2 times, so we can write 2 times cos A. Now in the denominator, we can open this bracket by using the anti A plus B whole square. So A square, that is cos square A, plus B square, that is sin square A, plus 2 times AB, that is 2 times cos A into sin A. And this is minus 1. Now, what happened? In the next, we will cos square A plus cos square A means we can write 2 cos square A plus 2 cos A. And in the denominator, you can see cos square A plus sin square A is 1. So 1 plus 2 cos A sin A minus 1. So 1 and 1 will cancel out. You will get 2 cos A common in the numerator. You will get cos A plus 1. And here in the denominator, you will get 2 cos A sin A. So it means 2 cos A and 2 cos A will cancel out. Now separate it. Cos A upon sin A plus 1 upon sin A. So this is cot A plus cos A. So this is nothing but your right hand side. So please always first watch your INT carefully. See what is given and what you have to prove. You can see on the left hand side cos and sin are there. In the right hand side you have given cosec and cot. Cosec is the reciprocal of sin and cot is nothing but the cos upon sin. So in the right hand side you can see the sin is coming in the denominator. It means what you have to do, you have to bring the whole expression in the form of cos in the numerator, because only then it will cancel out and you will get sin in the denominator. Now come to the next question. Root of 1 plus sin A upon 1 minus sin A. So what we have to do, whenever you get such kind of question that square root sign is there, most of the time we multiply both numerator and denominator by the conjugate. So we can write this one is 1 plus sin A upon 1 minus sin A. Now what is the conjugate of 1 minus sin A? The conjugate of 1 minus sin is a 1 plus sin A. So multiply both numerator and denominator by its conjugate. Now, here you can write square root of 1 plus sin A whole square. Now, in the denominator, you can see A minus B, A plus B. That is A square minus B square. So 1 minus sin square A. So if you separate it, What you will get square root of 1 plus sine A whole square. And the geometry you will get 1 minus sine square A, that is cos square A. Now this square and square root sign will cancel each other, so you will get 1 plus sine A in the numerator, and the denominator you will get cos A. Now separate it. When you separate it, you will get 1 upon cos A plus sine A upon cos A. So take the LCM, you will get 1 plus, or you say separate it. When you separate it, you will get 1 upon cos A plus sine A upon cos A. And here you will get sec A. 1 upon cos is nothing but the sec A. And sine A upon tan A is nothing but, sine A upon cos A is nothing but tan A. So you will get sec A plus tan A. So please remember this one. Whenever you have given any INT, see left hand side and right hand side both very carefully. You can see sec is nothing but the reciprocal of cos, and tan is nothing but the sine upon cos. In both the cases, the cos is coming in both the terms, cos is coming in the denominator. So it means you have to just make your simplification in such a way that cos should come in the denominator. So if you just multiply by its conjugate, then you will get 1 minus sine square A in the denominator. And this is nothing but the cos square A. And when you just take the square root, you will get the cos A. Now, sin A plus cos A whole square plus cos A plus sec A whole square is equal to 7 plus tan square A plus cos square A. So see here, in first bracket, you have given sin and cos A. In the second bracket, you have given cos and sec. Fine. So what, and one more thing you can see here, the power is given. So first you will solve the power by using the INT A plus B whole square, which is nothing but A square plus B square plus 2AB. So see what happened. So if I see, whenever you have given any number on the right hand side, which is constant, so you can see the 7 is constant, no trigonometric ratio is written along with that. So it means either it will come in the form of sin square theta plus cos square theta, or sec square theta minus tan square theta, or cos square theta minus cot square theta, because they all are equal to 1. So only in that case you will get this number alone. So you can see if you do the square of it, so here you will get sin square A, here you will get cos square A. So it means you will automatically get 1 sin square A plus cos square A. Fine, so just try it. First we will open this both the brackets by doing the square. So A plus B whole square is A square plus B square plus 2AB. So we can write sin square A plus cos square A plus 2 sin A into cos A plus cos square A plus sec square A plus 2 cos A sec A. Now we can write sin square A and cos square A together. So we can write sin square A plus cos square A. Now you can see in our right hand side, cosec is not coming, it is coming cot. So we can write it as 1 plus cot square A. Now plus 2 sin A. Sin A and cosec A are reciprocal of each other, so we can write it as cosec A as 1 upon sin A. Yes, sec is there, but in the right hand side, sec is not coming. It is coming 10. So we can write the INT 1 plus tan square A. Now, plus 2 cos A. So sec A is a reciprocal of cos, so just put the value. Now you can see, they will simplify. You will get sin square A plus cos square A is 1. So 1 plus 1 plus cot square A plus 2 plus 1 plus tan square A plus 2. Now add all the constant terms. So 1 plus 1, 2, 2 plus 2, 4, 5, 6, 7. So you will get 7 plus tan square A plus cot square A. So this is nothing but the right hand side. See, you can see it very easily that why I have not converted it into sec into cos and cosec into sin, because we know that if I do the square of this bracket, I will get sec square A, and we know the relation of this sec square A with tan square A by this sec square A is equal to 1 plus tan square A. We know this identity sec square A is equal to 1 plus tan square A. So if I do the square, I will easily get tan square A. Similarly, we know the relation between cosec square A and cot square A, because cosec square A is nothing but 1 plus cot square A. So if I do the square of it, I will get square, and by using the IMT, I will get cot square A. So this time, I'm not going to just write cosec A as 1 upon sin A and sec A as 1 upon cos A, because we want tan and cot, and we know the relation between cosec square and cot square and sec square and with tan square. Now in this question you have to prove 1 plus tan square A upon 1 plus cot square A is equal to whole square of 1 minus tan A upon 1 minus cot A, and is also equal to tan square A. So what we have to do, first we will see this 1 plus tan square A upon 1 plus cot square A. If you know the identities very well, then you can easily observe that we have an identity sec square theta is equal to 1 plus tan square theta. So here we can write 1 plus tan square A, it is given. So here we can write sec square A in place of 1 plus tan square A. So this is sec square A, and we know the relation of 1 plus cot square A with cosec square A. So we know that 1 plus cot square A is equal to cosec square A. Now convert it into sine and cos. Sec is a reciprocal of cos, so square is over there, so we can write it as 1 upon cos square A. This is 1 upon sine square A, because sine and cosec are reciprocal of each other. So we can write, now this bring sine square A in the numerator. You will get sine square A upon cos square A. So sine upon cos is nothing but tan, and square is over there, so we can write tan square A. Now if we see 1 minus tan A upon 1 minus cot A, and square is over there. So we don't have any identity on tan A, we don't have any identity on cot A. Fine, so at that time what we have to do, we will just convert them into sine and cos first. So 1 minus sine A upon cos A upon 1 minus cos A upon sine A, because cot A is cos A upon sine A and whole square. So if you just take the LCM, you will get cos A, and this is cos A minus sine A, and again just take an LCM, you will get sine A minus cos A upon sine A whole square. Now you can write it as cos A minus sine A whole square upon cos square A. If you take minus sign from it, because here if you see this cos A minus sine and sine A minus cos A, they are just same, but the difference is with of sign only. Here sine is negative, here sine is positive, here cos A is positive, here cos A is negative. So we can take minus sign common, and since power 2 is there and 2 is an even number, so the minus sign will become positive. So we will get here cos A minus sine A whole square, and here we can write sine square A. So this one will cancel out. You will get sine square A upon cos square A, and this is nothing but tan square A. So here we can see easily that 1 plus tan square A upon 1 plus cot square A is equal to tan square A, and also 1 square of 1 minus tan A upon 1 minus cot A is also equal to tan square A. So this is all in today's videos. I hope you have liked my video, and in the next video we are going to discuss the questions of trigonometry of this chapter, board questions especially, which came in 2020. So please don't miss that video and watch it definitely. So till then, goodbye. We'll meet you in the next video. Thank you for watching my video. If you like this video, please give a like to this video. Share this with your friends and subscribe my channel. And yes, don't forget to press a bell icon to get a notification for my new videos.